Here we go. Just going over this quiz for those of us that wanted to make sure that they got everything right. For this first problem, we have a 60 kilogram person in a sled. You don't need to be able to draw these accurately. We just need to be able to represent different objects that may or may not be moving, different speeds, and how they behave before and after collisions. So here I have 60 kilograms traveling at 3.8 meters per second, and it's going to collide, and essentially what I end up with after this collision is both of these moving together at some final velocity. To calculate the initial total momentum, well, that is only going to be the momentum of the person because the sled isn't moving. So the initial total momentum is just going to be, if you look at the situation, that's going to be 60 kilograms times 3.8 meters per second plus, that's just a big fat 0. That makes sense. And we're going to get 228 kilogram meters per second. If you know anything about collisions, you know that the final total momentum is equal to the initial total momentum. All right, if you're a true believer, that won't be a problem. After they collide and stick together, well, what do I know? I know that the total momentum final is 228 kilogram meters per second. If I go back up and check out my diagram, I have both of those objects moving together. That means that they are really going to be moving as one big 72 kilogram object, and they will have the product of their mass and their final velocity has to be 228. I'm going to divide both sides by 72, and I'll get the final answer of the two. It's going to be 3.167, somewhere around there, depending on where you decided to round, meters per second. If you didn't calculate this correctly, you should at least understand that the final speed will be less. Why? Is because the momentum has not changed, but the mass of our system really has. Or the distribution of that momentum has changed, where instead of all the momentum being in the one person, it has to be shared. It'll be shared at a lower velocity to still give us the same momentum. All right, this is one second situation that we're dealing with. Really begs you to draw the appropriate diagram. So they have the same masses. I've got red, and since I've got the option, I'll go ahead and make blue. Nothing said that red and blue had to be in this relationship, but right or left. But the point is that red or blue, they are moving towards each other at two different velocities. The red is moving at 3 meters per second. The blue is moving at 2 meters per second. 0.25 kilograms, 0.25 kilograms. So to find the total momentum, I'm doing the vector total momentum. All right, these are vectors. They have direction. So total momentum initial is going to be equal to, well, let's just go ahead and define my system here, where I'm going to say to the right is positive. It would work just as well to say that it's to the negative. It'd work the same way no matter which way you arrange these balls. The initial total momentum is going to be the mass of the red ball multiplied by the velocity of the red ball. And that velocity is a positive 3 meters per second. Going to be adding that to the, let's get these all in parentheses just to make it very obvious what we're doing. I have the mass of the blue ball, again, 0.25 kilograms. And I'm going to be multiplying that times the velocity of the blue ball, which is negative 2 meters per second. So we can see here that because they're in opposite directions, when I think about the total momentum, it's actually only going to be 0.25 kilogram meters per second. Okay? We need to make sure that we didn't end up with more momentum. This was 0.75 for the red mass and negative 0.5 for the blue one. I add those together, I get 0.25. Again, 0.25 final total momentum is equal to the initial total momentum. After this collision, I know that let's go ahead and say after this collision, what I do know is that the red ball has come to rest. So the red ball has 0 velocity. I want to know what's going to be going on with this blue one. I don't even have to know the direction, but maybe a little bit of intuition would let me know that since the total momentum to the right was to the right and the red ball was not moving, the blue ball must be moving to the right. But I have no idea about what its speed is. Well, we can solve with this even if we didn't know the direction, because all we have to do is say that that final total momentum is going to be equal to 0.25 kilogram meters per second. That is our final total momentum as well as our initial. But in the final situation, it will only be the blue ball that has that momentum. The red ball has stopped. So that must be equal to 0.25 kilograms times V. Oh, well, that's obvious. Divide by 0.25. V is going to be equal to 1 meter per second. If I continue down this road, how is the blue ball moving after this collision? Well, the blue ball had a negative velocity initially and a positive velocity finally, so it would be moving in the opposite direction than its initial. It doesn't matter which way you chose to be positive or how you set this up. Anytime you looked at this, the blue ball would be reversing its direction. All right, lastly, this is just a question that really asks us to do all these same types of things, but kind of do them all at once and not such a scaffolded, hey, do this first, do this second. Find the final velocity after the collision. I have 2 separate things before the collision. I've got 2 separate things after the collision. Before the collision, I have 2,000 kilograms moving at, 30 meters per second. I have the car, which is 5,000 kilograms, moving at 10 meters per second. After this collision, I have 5,000 kilograms moving at 12 meters. Oh, wait, no. The car is moving at 12 meters per second. And we want to know what the final velocity of this truck is. So, how do I get my total momentum? Just add up the 2 momentums. This is initial total momentum is going to be equal to 2,000 kilograms times 30 meters per second plus 5,000 kilograms times 10 meters per second. That should give us, what, 50,000 plus 60,000, 110,000 kilogram meters per second. I'm going to just double check my math on that, but I think that's right. Yes. So, well, we know that the initial total momentum is equal to the final total momentum. So that 110,000 kilogram meters per second needs to be accounted for by, well, I got 2,000 kilograms times 12 meters per second plus 5,000 kilograms times whatever that final velocity is going to be. So I've got to, on both sides of this equation, subtract this would be 24,000 minus 24,000 86,000 kilogram meters per second is equal to 5,000 times VF. Divide by 5,000 on both sides. And you would get a final velocity, VF, is equal to 17.2 meters per second. Hope that helps.